Alright, so tonight we're going to do some change of variables, transformations, and hopefully this goes smooth. Got all my notes right in front of me. They're all right where I need them, so let's go. So suppose you have y is equal to, we have some function rather of x that is 3x squared. And it's PDF. Again, I always like to double check that it is, so if I integrate this from 0 to 1 of 3x squared, y, that's x cubed from 0 to 1, which is 1. So check, it is a PDF. So here we go. So let's suppose I want to know, well, let's let y equal x squared. Okay? Well, in order to make this substitution, I'm going to have to solve for x. So x is obviously the square root of y. Positive only because of this bit right here. Okay? So you're like, okay, well, let's start making our transformation. So instead of being f of x, it's going to be f of, well, x, right? So it's 3 square root of y squared. That's so far so good, right? That's not too hard for everyone. We feel good about this. Now, we need to go a step further. So we're going to let x equal this deal. So then dx is equal to 1 over 2 square root of y. Like so. Okay? So if you combine those, you're going to get obviously 3 halves. This is y divided by the square root of y is the square root of y. Okay, so this is now a function of y only, right? And so this is just our function of y only. Then the question is simply, what are our y's doing? Well, as you can well see, our y's are going from 0 to 1. How do I know this? Because if you plug this guy into here, what do you get? 0 squared is 1. You plug this guy into here, what do you get? You get y is equal to 1. Okay? That's the game. That's about as easy as they make them right there. Nice and continuous. Easy to do. One variable. Boy, you can't hardly mess that one up. Here's one that's just a skosh trickier. Suppose you have f of x is equal to 3. 1 minus x squared. Again, 0 to 1. Let's again verify this. 0, 1, 3, 1 minus x squared dx. Well, this is going to be 3 and then 1 minus x to the third over 3 and then times by negative 1, right? Because you need to use technically you're using a change of variable here too, because you're letting u equal 1 minus x, so du would be equal to negative of a dx. Well, that means I have a negative du. Okay? And, whoopsie daisy. So that's how I would have done it if I was doing a substitution. You with me? But I didn't do substitution. I did it in my head. So this is my answer. So these guys cancel off. I'm left with negative 1 minus x to the third power from 0 to 1. So at the top end, you're going to plug that in. You get 1 minus 1 is 0. So you have 0 minus. And at the bottom end, you put a 0 and you're going to get 1 minus 1. So minus a minus 1. Lo and behold, it works. Again, just get in the habit of checking those. You save yourself a lot of headache and misery. Now check it out. What if I said to you that y was equal to 1 minus x cubed? Okay? Now, by the way, if y was equal to 1 minus x, that's literally the same thing as saying u is equal to 1 minus x. Am I right? So, in reality, when we did that antiderivative by plugging the u in, we've already done this in the past. You with me? So, like right here, when we said, hey, let's let u equal this bet right here, then we changed this guy here to 3u to the second power with a negative in front of it. In other words, you have already done, if you will, the change of variable formula. You've already done it. So you're already accustomed to that. Now, that's not what we're saying here. We're saying that is the general idea of what we're doing. But if I were to do this, I'm going to plug this into in place of x. Are you with me? That doesn't seem very hard. So it's going to be 3, 1 minus x to the third power, yes? There is 1 minus x. This is x squared. Okay? Now let's see what happens when we distribute this negative. Stop it. These guys go away. This becomes a positive. the 1's cancel out and you're left with 3 x to the, well, sometimes I get in the habit. I totally looked away from my notes. And then I was like, oh yeah, no. Okay, Jay. Anyway, my point is we've done this before, but here's what we need to do. We need to solve for x. So x is equal to, because that's what we need to solve for. What an idiot. X is equal to 1 minus the cube root of y. There we go. Now let's try this again. So it's f of x. There we go. So it's 3, 1 minus x squared. Right? Now let's look at that for a minute. Okay, well, cool. So then if I distribute the negative, that's negative, that becomes a positive. Sweet. These guys cancel out, and you're left with 3y to the 2/3. And that part of there is just the substitution. What we have not done yet is we have not taken into account the Jacobian, or in this case, just the dx. Right? That's my Jacobian. So I'm going to multiply by that right here. Notice that we're not going to bring the negative with us. We're just going to leave it the positive with us here. Okay? Because it is a Jacobian, and the Jacobian always positive. So up here, when I said that we've done this before, you with me? It's the same thing, the difference being is we wouldn't have put the negative there, right, if we were doing the same kind of change of variables. And when we're doing integration, we want to need to put the integral right there. When we just talk about substituting it out, we don't need to fool with that. So notice if you look at this, these guys cancel, and you're left with simply 1. Now, where does that go from? Well, we're talking about y. Now look at y. Y is equal to this mess here. Again, you plug 0 into here, you're going to get 1 minus 0 is 1. 1 cubed is 1. Put a 1 in, you're going to get 0. So it sure looks like our y's run back and forth between 0 and 1. Right? There's 2 of those. Let's try, not that one. Let's try this one. I kind of dig this one. It kind of makes me happy. So let's just say that x and y have this joint PDF. Now, as soon as you see it, you will go, oh, I've seen this before. And you have. By the way, if you don't say that, I'm going to be a little angry. Just saying right now. 1 over square root of 2 pi. Hey, that sounds like a normal. It is a normal. You're not wrong. Now, I'm going to write it like this, just for fun. I want to point something out to us. That guy right there, says that they are independent. How do I know that? Because if you have a PDF, right, a joint PDF where it's a product of 2 things, where this is only x and this is only y, that x and y are independent of each other. Now, so they are both standard normals. Okay? Now, I'm going to say let's let u equal x plus y. For no apparent reason right now other than I feel like it. And v is equal to x minus y. We can do all kinds of changes. We can do whatever we want. Just some nice easy ones here. If I solve for x, and again, I'm going to show you this on my calculator. Here's the deal. I could solve this. I had nothing but time. I wanted to impress the ladies. You could really impress them with some algebra. Yeah, I'm not doing that. So here we go. So I'm going to go down here and I'm going to go to solve, which is under F2. Solve. And I'm going to say u equal x plus y. And, so that's second, 5, 8, 8. V equal, whatever V is, equal x minus y, comma, squiggly brackets, x, comma, y, squiggly brackets, parentheses. And there you will get u plus v over 2. And you will get y is equal to u minus v over 2. Again, if you're a glutton for punishment, if this just really makes you happy, I'm not going to stand in your way. You're like, I'm going to add these 2 functions together. Cool, then you get u plus v is equal to 2x when you add them, yes? Boom, done. You with me? Okay, I'm going to minus these two functions because when I minus them, the x's will go away. Cool. So I'm going to get u minus v is equal to 2y. So y is that, right? So that's how you could do it. And that's not bad if you see it, but sometimes it's hard to do them. Sometimes they aren't as nice and pretty as this one. So it really is just one of those things. Use a calculator, for goodness sakes. Now let's look at the Jacobian. So the Jacobian is dx du, dx dv, okay, 1/2 minus 1/2. So this is going to be minus a quarter is minus 1/2. Absolute value of that is positive 1/2. So what am I going to do? I'm going to come up here, and I'm going to take my function of x and y, and I'm going to make it a function of x, yes, and y. Right? Right. Right. And so it's 1 over 2 pi, square rooted, yep, e to the minus x squared over 2, right? Times 1 over square root of 2 pi over 2, that's inside the parentheses, 2 over 2 times 1/2. Now I'm lazy. 1 over root 2 pi, 1 over root 2 pi is 1 over 2 pi. But then there's also a 2 here on the bottom, so it's 1 over 4 pi. Now, I'm going to go ahead and write this twice just because I'm a weirdo that way. This is really going to become, this is over 4 in here when you square it. And then divided by 2 is going to be over 8. So what I'm going to do is I'm going to put a negative here. And they both have a negative, so I'm just going to put all of it in a negative like that if you don't mind. And then all over 8. Okay? And so when we FOIL this out, you're going to get x squared plus 2xy. That's a y right there, stupid. No, it's not. It's u plus v. And this is u minus v. Okay, so I had kind of it right. And that's just gross. Try u squared plus 2uv plus v squared plus u squared minus 2uv plus v squared. Now, if you combine your like terms, these dudes go away, like so. And you're left with, if you don't screw that up there, you're left with negative 2u squared, and then it's plus 2v squared. You see that like that? All over 8. And you can cancel a 2 out of there, and you'll end up with negative 1 over 4 pi e to the negative u squared plus v squared over 4. That is my function. And then, well, did I change anything? Well, I took infinity plus infinity and negative infinity minus infinity. So u is going from negative infinity to infinity. And v is also doing the same thing. Okay? Once again, u and v are independent because I can break this back into 2 pieces if I like. So I could rewrite this as 1 over 2 square root of pi, I guess. E to the minus u squared over 4 times 1 over 2 square roots of pi e to the minus v squared over 4. And because they're written like this, those guys are still independent of one another. Yeah, that part there is neither here nor there for you. I just like to mention it here at this juncture. Okay? What else we got for you? What else? Oh, let's do this one. That one looks fun. Here is another one of my notes pages. So, nice. Let's say you got x and y of a joint PDF. Again, joint PDF, that means they vary, they're in there together. In this case here, if it's some f of x and y, I want to mention this again, it's x e to the negative x times e to the negative y. X and y are both positive. Okay? 0 elsewhere. Check it out. These guys are also independent. There's your function of x alone times your function of y alone. Again, not that it really matters, just saying there it is. Let's let u equal x plus y. Let's let v equal y over x. See, this is one of those ones where it's not so easy to solve for them. I mean, maybe it's not terrible, but it's not easy. So I'm just going to go ahead and turn my calculator back on, go solve. U equals x plus y. Not comma stupid. Second, math, 8, 8. And then I'm going to do v equal y divided by x, comma, squiggly brackets, x, comma, y, squiggly brackets, parentheses. So I will get u over v plus 1, so x equals u over v plus 1, and y equal uv over v plus 1, uv over v plus 1. That's beautiful. Okay? Now, my original function is up here. So first things first, let's go make ourselves a function of x and y. So everywhere there's an x, I'm going to stick one of these dudes in. That doesn't seem very hard now, does it? No. Like so, yes? So that's basically it, except for now I need the Jacobian. So the Jacobian is going to be 1 over v plus 1. And you're like, Jay, I can't do that in my head. Good, I got you covered, bro. So what I'm going to do is I'm going to come in here, and I'm simply going to say, let's take the derivative of u divide by, parentheses, alpha v plus 1, parentheses, comma, u. So there's that. Feel good about myself. Now change that baby to a v. And so it's negative u over v plus 1 squared. And oh, screw that. Okay, here we go. And we'll take the derivative of, now this is where it gets going to be a little weird here, so make sure you pay attention to this. It's going to be u times v. If you don't put the times there, it will not work. You'll be angry. You'll be cussing your calculator. She'll be saying, why are you yelling at me? Because it's your fault, because Jay told you. There it is. So it's v over v plus 1. I think I said, and change that baby to a v. U over v squared plus 1. U over v plus 1, sorry, squared. So if you take that, this times this, you're going to get u over v plus 1 squared, cubed rather, minus, so plus uv over v plus 1 cubed. So you're going to get u plus uv over v plus 1 cubed. That thing right there is your Jacobian. By the way, if you go back and look at Calc 4 book we used, the book we used in Calc 4, I am 99.9% positive, although I was too lazy to go look it up, that this is one of the problems that's actually in the book when it talks about doing the Jacobian. I distinctly remember this particular problem. It was not couched quite this way, but it was talking about, suppose you have this function, you want to do a change of variable on it. Okay, bam, there you go. Now, clearly we can make this a little prettier. So I'm going to combine my like terms out front. And when I do that, bloop, over to here I'm going to get u. I'm going to pull a u. I'm going to pull a u out of these two guys on top, and there's a u here, so I'm going to have u squared, and then I'm going to have 1 plus v. On the bottom I'm going to have v plus 1 to the 4th power. Wait, that and one of these cancel out, yes? So I'm going to really end up with u squared over v plus 1 cubed. And then it's e to the u over v plus 1, negative. And then times e to the uv over v plus 1, negative. Okay, everyone follow that? All right, I don't hear anybody complaining, so I'm going to keep going. V plus 1 cubed. Now, these guys have the same exponent, or base, so I can then add my exponents, correct? And put them both inside of a parentheses and put a negative out front if that's okay with you. Well, hey, wait, we just did this guy. We could rewrite that then as u squared over v plus 1 cubed. This is e to the minus, and then I can pull a u out. Pull the u all the way out here, I guess. Because I feel like it, and then that's going to be 1 plus v over 1 plus v. What? Look at that. Look at it. Look at it. Look at it. And so you end up with this guy right here, which is u squared, e to the minus u, times 1 over v plus 1 cubed. Well, gee, look at this. Our u's are by themselves and our v's are by themselves. What does that say about our u's and our v's? It says they're independent, friends. That's what it says. Which is interesting because one would imagine that if one started with independent functions and then one made transformations, one would be shocked, I think, if one didn't find them to be, independent again when you're finished. And so I think that's kind of a neat thing that works out that way. Okay? Yeah, and that's it. So it's kind of a neat deal when you can work through those guys and see that. Okay? All right. So anywho, there's that. So then, yeah. Oh, okay. Now we'll back up to here. What were our x's and y's doing? Our x's and y's were positive. Okay. So we took x's and y's and we added them. Positive plus positive is positive. We divided them. Positive plus positive, or positive divided by positive is positive. So these guys are both also greater than 0. Okay? Questions on those at all? No? That's the kind of thing you're going to be doing. Not terribly difficult. I don't think. You can find them to be quite fairly straightforward-ish. I think I want to do one more. So I'm going to pause for a second because I can't find where I stuck that piece of paper. Okay, here it is. So we're going to do one for the binomial. So we're going to say that let's let x be distributed binomial. Oh, shoot. That's weird. So let's let x be distributed binomial. And n is 3 and p is 2/3. It's always n, then p. Okay? And so we know going in that that's going to be, well, let's try this. It's going to be n choose x, yes, n choose x. And it's going to be p to the x, q to the n minus x, right? So let's think about this for a minute. So I got this, all right, so that's going to be 3 choose x, whatever. And it's going to be 2/3 to the x, and then 1/3 to the 3 minus x, true? That's cool. All right, tell me something I didn't know, Jay. I'm on it, pal. I'm on it. So then let's think about this for a minute. Two things. First of all, we need to change a variable. Let's let y equal x squared. Of course, that means x is square root of y. Again, we know binomial. X is going to go 0, 1, 2, and 3. Those are the only choices. Because x is positive, y is also positive. Notice, though, that y will be these guys. See that? That's what y will have to be. So we'll keep that into mind. See, down here in these discrete ones, those guys happen to come up in like a different order. I mean, usually I say that part for the end, but with the discrete, it kind of just, blah, there I am. Okay? So cool. So what is a combination? Well, if you remember that n choose x can be written as n factorial over n minus x factorial times x factorial. I can break this out to, not like that, stupid, like this. Right? And then I'm going to have 2/3 to the x, 1/3 to the 3 minus x. Okay, now it's time to substitute, right? So this is f of x. Well, I want f of x. See that? Isn't that nice? So So it's going to be 3 factorial over 3 minus the square root of y factorial, square root of y factorial. 2/3 to the square root of y. 1/3 to the 3 minus square root of y. Okay, so far so good. That's all, folks.